Okay, so when we talk about innovation, I want you to think back to times in which you have innovated or tried to innovate something in your shop, whether it's bringing in a new piece of equipment, rearranging the layout of your shop, maybe shuffling up your departments, maybe offering a new product line. If you've never done rectangular duct, maybe doing that. If you've never done residential, maybe doing that. Think about some ways in which you've tried to innovate and what have been some roadblocks that you've come up against while you've practiced innovation in your shop. What do you think? And by the way, we love these to be interactive, so please do speak up. We'd love to hear from you. Question us, push back, shout out. What are some roadblocks to innovation that you've experienced in your shops?
Hey, Graham, this is Jamie. For us, we have tried to implement some lean practices, and what we get is a lot of feedback we get is, hey, we've never done it that way. We've always done it this way. This is what works. This is where we want to stay. So that's some of the roadblocks we face from time to time when we try to implement new things.
Must just be a North Carolina thing, Jamie. We experience the same. That and you know, once we get a little further ahead, you know, once we get all of this work done, then we'll talk about it. You know, I guess procrastination.
Yeah. Brady, were you going to chime in?
No, I got nothing right now.
Okay. Yeah, I'd say
I would just say that both of those scenarios that Jamie and Robin talked about are so normal.
Mm-hmm.
It is
even outside of North Carolina.
Yeah, it's not isolated to a certain area. It's universal because we're dealing with folks who, you know, they're doing their work. Some of these folks have got experience, you know, 10 years, 15 years of experience. And so they really actually don't understand that they can expand and improve and make changes. They think that their job is to keep it status quo. And so it's a very normal thing. And the thing about, as soon as we get done with our priority right now, which is getting the customer product out, again, that's the whole point of being in business, is to get the customer product out on time. And so you've got to kind of force that cultural change to say, we're going to spend some time to work on the business. So yeah, it's a very normal thing.
Yeah, I hear those two issues come up all the time. It's like, well, we've always done it this way. Why do we need to change? And we just don't have time. Those are super common roadblocks. Thanks for sharing those. Anybody else want to chime in and share? Going once, going twice. All right, Dale, why don't you take this next one?
Okay, so once you have had those types of responses, what has been your way of handling it? What have you guys responded with?
So our response typically falls in line with what Robin said, and that usually coincides with us getting busy, and then it falls on the back burner, and 6 months later we try to address it again. So
yeah, same.
And so the process of reinitiating the efforts is actually a great way of showing the team that this is not a flash in the pan type of an interest, that this is something that the leadership team really wants to work on. So it takes patience. Sometimes it takes a lot of patience, but you know, being persistent is the way to kind of break through on that, for sure. Thanks for sharing on that.
Yeah, great input there. And I think, yeah, I would say that what you guys are doing is super common to it. It's like, you know, something more urgent takes over. We call that the tyranny of the urgent. And you back burner your initiatives, and then it's like you things slow down again. You're like, oh yeah, remember this thing we're supposed to do over here? Yeah, that was we determined that to be the most important thing to do on January 1st, and we haven't done it, and it's almost September, right? I mean, there's probably nobody on this call that's thinking that about any of their initiatives that they set out on the beginning of the year. I don't know if you guys do New Year's resolutions, but boy, I have had setbacks and failures on pretty much every single one that I set personally on January 1st. So I know I'm probably the only one here that can say that. And how have I handled them? Well, not great, if I'm being honest. But I think I have a lot of room for improvement, which I think is why we're all here. Is we want to improve the way we innovate. We want to improve the way we approach projects and new initiatives. And to do that, we're going to take a little bit of time and study this amazing company called SpaceX. Now, regardless of how you feel about SpaceX, regardless of how you feel about Elon Musk, the founder, you know, he's a little bit of a space cowboy, maybe not as much as Jeff Bezos with the literal cowboy hat. You saw that stunt a couple weeks ago. But regardless of how you feel about this organization, they have done some incredible things. And I'm going to pass it over to Dale, who's going to kind of tell you about some of the innovations that this company has done and really turn the world on its head from an engineering perspective. So Dale, take it away.
Yeah, so SpaceX is just a fascinating company to me. You know, Elon Musk, you know, made his billions, totally doing something different. And then he got this vision for space flight. He really has a vision for making space flight inexpensive. And, you know, his big, hairy, audacious goal is to be the one that ferries people between the moon and Mars. And that seems sort of, as I say, it's like, wow, you know, but, you know, if he's looking down the road, you know, into the future, you know, we are going to be needing vehicles that can take people to our neighbors, our space neighbors. But he also realizes that the current model of rocketry is unsustainable. You know, it cost, even back in the Apollo program, it cost billions of dollars to put, I think it was 14 people on the moon. And so he's really redefining how rockets should be used. And his big thing is reusability. Excuse me. And so he has really started pushing towards a reusable rocket system. And he's spent a lot of money for sure, and he's got the resources to do that. But he's also gotten pretty close to being bankrupt because of the efforts that he's put together. And it wasn't until Falcon 9 that he really turned a corner with the SpaceX team and began successfully reusing the rocket. And if you've seen any of the videos, if you haven't, just go to YouTube and Google Falcon 9, and there's just a bajillion hours of video of these Falcon 9 launches and landings. And to give you a perspective, the Apollo and most rockets are disposable. The Apollo program with men being sent to the moon, they were disposing the entire rocket. In fact, the only thing that was recovered was the command capsule with the 3 astronauts in it. And from a weight standpoint, that equates to 0.18% of the total weight recovered from the rocket. And Elon is looking at recovering over 90% of the rocket every time they launch it. And but it didn't come easily. And that's really what we want to kind of focus on, is that there was a process that they took to change the way rockets were launched and recovered. And some of it's just comes right out of the Jetsons, right? And as you'll see in a minute, where he's launching a rocket and then having it come back down to Earth and land, back on, in a upward position, and so it's just crazy stuff that 5 years ago would have just been mind blowing. It's actually mind blowing now.
It's still
So
mind-blowing.
yeah, it's still mind blowing. So what I want to do is just kind of show you a montage video of what it took for them to get the Falcon 9 rocket to be successfully being recovered. And then also their newest ship called the Starship. This is the Starship is going to be used for human transportation as well as cargo transportation to the moon and to Mars. And so we'll just jump right into the video. I'll be talking over it a little bit to point out some stuff here, but we can go ahead and get started with the video. So this is just basically one of the first launches that they did of a rocket. And so here is the Falcon 9 trying to land, and they just couldn't get it. Not only are they landing on the ground, but they're also landing on a barge out in the middle of the ocean. And it took over 20 attempts for them to be successful at landing these rockets. And it makes for a spectacular video for sure. But here's the first time that they were successful at landing the rocket on land. Here's the drone ship landing that they successfully did. And that's just amazing to me. Then they also have a super heavy, which actually takes 3 rockets and bolts them together. And 2 of those rockets get reused. And as you can see here, this is the first time that both rockets land successfully on the ground. And as you can see here, as of May of this year, they have successfully landed 100 rockets. Now the Starship, much bigger rocket, these are test flights. They're taking them up to 32,000 feet. And then they do a belly flop. They literally flop this thing on its belly. And then it comes, and then at the last moment, it flips back and, with its tail down, and it's supposed to land. Well, it didn't quite make it the first time. And in fact, after that first launch failure, Elon's response was, "Congrats, SpaceX. We got a lot of great data from that flight." So this is the second flight. Engine problems caused it to come down really hard. Third attempt, it looked like a very successful launch and landing. And so this is the first time that the rocket did not crash. Unfortunately, 8 minutes later, it just got too hot. There was a fire and it got too hot. And then this SN11, they've launched in fog, so they really couldn't see what happened. But during the landing maneuver, it exploded midair.
Bummer.
Yeah.
And I
so,
thought I spent a lot of money on fireworks.
Yeah. And so all they have for video is just the shrapnel coming down. And then now they skipped a bunch of rockets and with an upgrade to SN15, and they fixed a lot of things.
Starship, heading back to the landing. Starface, flight control
And this was even though there was a little fire, it was not a catastrophic thing. There was no explosions. So everything was successful. And they are now preparing to put that rocket on a bigger rocket for a orbital flight.
Which should happen in the next month, right?
Yeah, yeah.
And this thing, when it's fully stacked, will be taller. It'll be taller than a football field is long by a pretty substantial margin.
Yep.
Football field and the end zones, right?
Yep.
You're not signing up for that ride right now, are you, Dale? You're not
I-
signing up yet?
No, I won't go on the first one, but I would go. I would love to go. But anyway,
Maybe the
so what did we just see? I mean, we just saw lots of failures, and think about the team that's involved with these rockets and developing these rockets. They had to go through the agony of defeat, if you will, every time one of these rockets failed. But they were persistent, and I think that's the key with innovation. They were persistent, and they followed this continuous improvement model that where we call it the plan, do, check, act model, where they take a plan, they engineer it, they execute it, and then whatever happens, they do analysis on the results. And then if it's not successful, make modifications, do the revisions, and then in this case, launch it again, and over again until you have figured out all of the issues that cause the rocket not to land where it's supposed to land. So that's really what this video is showing, is the continuous improvement model in creating something brand new in the market. In this case, a reusable rocket that can land on its own. And so that is really the what we want to kind of focus on going forward here today, is what does that look like in the continuous improvement model that we teach with Lean and at the DMA. So I want to pass it over to Brady on this, just to talk about how do we become more like SpaceX, even though we don't have $1 billion to spend. How can we do that in our own shops and get the same amazing results that SpaceX is getting? Brady?
Thanks, Dale. So as we mentioned earlier, we run into this mindset with the people out in the shop or making our product that this is how we've always done it. This has always worked. Why do we want to change? Why fix it if it's not broken? So what we want to do is we actually want to create a culture of curiosity. So to start out, there are two ways you can learn: your mistakes or failures in this case, and the mistakes of other people. So your mistakes that you make are the hardest teachers. They teach you the hardest lessons, but they also seem to be like the best teacher, because you actually take to heart what you learned. You know how you got there. You know how to get out of that situation in the future, and you're better equipped to problem solve in the future. A great example of this in my life is when I was in my early 20s. I always knew that you should do oil changes in your car. I knew you should always check your oil when you get gas, and I didn't do it. I was about 1,000 miles over driving back from Portland, Oregon, and all of a sudden my engine started ticking. So even though I knew I should do it, people have always told me I should do it, I thought I was smarter than everybody else. And then I had to get a new engine. So the mistakes of others can give you knowledge of how to handle a problem, but it doesn't give you true understanding of that problem, how you got there, how you move forward. So I understood that I should change my oil, but I didn't do it for whatever reason, or check it, I guess. And I ended up learning a pretty rough lesson, and I still take it to heart today, 10, 12 years later. So is there an example of like a mistake or a failure in your life that has taught you a lesson that still sticks with you to this day?
I can think of plenty personally.
Yeah, what do you got?
There's so many, it's hard to even know. I think your oil change example is so great. I think I see this, having 3 young kids, I see this play out all the time at home. But when I think about a work situation, I think we all have those situations. I used to work in warehousing, and there were situations where you're supposed to put your seatbelt on before you operate the forklift, right? I mean, that's pretty basic safety stuff. You know this in your head, but when you are 19, 20 years old and you step on this forklift and you get anything with an engine in it, you put a 19-year-old on it, and things are going to happen. And so I don't need that seatbelt. I'm just moving forward. And then of course, you have to slam on your brakes. You hit something and you smack your head on the roll cage or something like that. And thank God, I mean, that could go so much worse, where you could fall out and get crushed. And these accidents happen all the time. But I think to a certain extent, you learn the right way to move forward. And then, but then you still have to figure it out for yourself. Like you still need that lesson. I think back to my kids. Every single one of my kids has touched a hot pan on the stove. After telling them, don't touch it, it's hot, you'll get burned, you'll hurt your hand, and it'll hurt for a week. And then, and now they know. So, I think, yeah, we never had baby gates when I had little kids. We never had baby gates on the stairs. Because they would take a tumble off a curb and they would know like, oh, I don't want to do that 10 times in a row. And so they learned really quickly to never go towards the stairs, because they had that understanding, which is knowledge that has been tested, is the way I like to think of that. So yeah.
Anybody else? Perfect. Well, we will move on then. So we want to introduce the concept of failing forward. So it's taking our failures, the lessons we've learned, and actually improving on them, and actually moving forward and improving the way we troubleshoot or experiment. So learning by experimentation and ultimately failing is the most powerful way you can improve. So we want to create that culture of curiosity. And we want to make sure that the basics are there with our people, that they have a desire to get better and that their brain is engaged in the process. So learning by experimentation teaches you many lessons, not only for improving the process that you are working on, but it also gives you this like knowledge base that enables you to take what you've learned by what you're doing and maybe say, oh, I was working on the coil line, but I fixed this problem and now I can use it over here making rectangular ducts. It's lateral thinking. So the lessons you've learned, the knowledge you've gained might not fix the problem you're actually working on now, but it can apply to something else in the shop. So ultimately your experimentation or the failures now have led you to improve other areas, or they've given you a knowledge base to make you a better problem solver in the future. But we have to remember that if we go into the improvement process with the fear of failing at the forefront of our brain, our creativity is stifled. The brain is super powerful and it is designed to solve problems. But if you treat it like a sticky note to remember like, oh, on the way home, I need to get gas and I have to go to the grocery store and get milk. And you treat it like
change your oil.
Change your oil. You treat it like a 2-cent piece of paper. That's all it's ever going to do for you. But if you free it up and you get rid of those worries of failing, and you don't want to look stupid and you don't want to waste money or time, if you free it up to not be worried and hyper focused on not failing, you can unleash this incredible problem solver, and your creativity and all your thinking power will just go through the roof. So the fear of failing is something that you can't really have. You want to be able to have your brain power freed up, and you want to be engaged and excited in the process. And you shouldn't be looking at it as a failure as actually a failure, because you're failing forward and you're gaining knowledge and you're improving and you're getting that knowledge base. So you need to be able to experiment, fail, and learn from those lessons without fear of repercussions. And the cumulative effect of those lessons turn you into a very critical thinker and a really, really excellent problem solver. And just a quick quote at the end here: there is no innovation and creativity without failure, period, end of sentence, ever, ever. So
What
do
do
you guys have
think
any?
about that quote?
Fantastic.
Does it ring true for you?
Most definitely.
That's a powerful, something we should all hang up in our shops.
Absolutely. And I think if you look back at the innovations that you have done in your shops, because everybody on this call has pushed innovation and has innovated in some way. That's how you've become successful, and everyone on this call is successful. So you have innovated. But think back to your own, where you're at right now, and the failures that got you there. It wasn't all a string of successes. I know it hasn't all been daisies for everybody on here to get to where you are. So think about that. Really, it's the failures that propel you forward and make you sharp and help you become that cutting edge innovative company that sticks around, that takes care of their people, that continues to grow, that remains profitable. It's the failures and not the day-to-day successes that make you. It's those overcoming those failures and using those to propel you towards greater successes. Brady, have you got anything else, or you want me to take it from here?
Yeah, that's about all I got.
Okay, so let's talk about this a little bit more now. So Dale has introduced SpaceX. We know this incredible innovative company is out there. By the way, when we looked at those videos, did you notice the second rocket, the big rocket? What did you notice about how that rocket looked? You remember?
Different.
It looked different for sure. It looked like something out of a sci-fi from the 50s. But let me, I'll throw a still shot of the video up here on the screen. What looks different about this thing? What's it made out of?
Stainless steel.
Bingo, stainless steel. These rockets, this is how innovative this company is. So when you think about rocket science, you think about a bunch of guys, maybe old Germans, I don't know, I kind of do. You think about a bunch of guys in lab coats, in a clean room, everything's white and bright. This rocket, the most innovative rocket on Earth, this rocket right here, was built in a tent outside in South Texas by sheet metal workers. This was built by the same people that are in your shop right now building duct. It's welded stainless steel. And when Elon came up with this idea, people thought he was crazy. But then they came to realize stainless steel was cheap. It had great thermal properties. It would make a decent rocket. It was flexible enough to be a good material for that. And so this rocket is over 90% stainless steel. So if you've been having trouble ordering stainless steel, you probably thank Elon for that too. He's gobbling up a lot of it down there in South Texas. But all these rockets are built out of steel, not carbon fiber, not some fancy moon composites, stainless steel. And I think that just turned the whole world on its head when he did that. So just another incredible example of innovation and pushing the envelope and not saying we can't do that, but saying how could we do that, which is such a substantial shift from maybe what our knee-jerk reaction or our standard mindset is. So let's talk about that process of innovation just a little bit more. And Dale touched on this briefly after the video, but we're going to talk a little bit about the PDCA cycle. So Robin, have you heard of the PDCA cycle, or anybody else on the call? Jamie, have you heard of this cycle before?
No, not for me.
I have not.
Okay, cool. That actually surprises me, because typically when people dabble in lean manufacturing or any kind of process improvement initiative in their company, this is one of the first things they kind of hear about is PDCA. And sometimes because of that, it gets a bad rap, because there's a lot of consultants or business professionals out there who say, PDCA, and they don't really teach you how to work through this process. But what this is it's a model for problem solving. So if we go back to the rocket idea, we start with planning. Okay, how are we going to make this rocket that can land itself so we can cut the cost of launching rockets by 90%? How would we do that? So the engineers go to work, and they go to work with the best knowledge that they have. And then we get to the do portion where they build the thing and they launch it, right? They use their best knowledge up to that point. They put the thing together using the peak of their skills, and then they launch it, and then something happens. It works, it doesn't work, it blows up in a fantastic fashion. Maybe it lands, maybe it falls in the ocean, whatever it may be. That's where we move over to that check portion where we say, okay, we use the best of our knowledge and ability to plan this out. We built the thing and we tested it out. What happened? That's what check is saying what happened. And then that final piece, act, is saying based on what we thought about, what we made, what we learned by making it, how are we going to act differently? Are we going to go build another one with our new knowledge? Are we going to build the same one again and try to get more data? Are we going to scrap this whole thing entirely? It doesn't really matter where you go from there, but you want to come out of that with an action for what you do next. So that in a nutshell is what the PDCA cycle is. And we at the DMA take this a little deeper and break it down, because one of the problems with PDCA is it's really up for interpretation. And so we like to put a little more meat on the bones there and really give you a recipe to be successful in your problem solving and your innovating. So we're going to give you that recipe in a second. But before we do that, I want to talk about why you would even want a recipe for this. And the first reason is that it standardizes the practice of both problem solving and innovation in your company. And so this is something that people don't necessarily do intentionally. They want to innovate, they think about it, they try something out, and then usually either it worked or it peters out after that because it didn't work. So this standardizes the practice of problem solving and says, hey, here's a recipe. So if you want to solve a problem or you want to innovate something, go through these steps and it's going to keep you on track. It's going to keep you focused so that you can come out of this with new information and possibly a new process or a better way of operating, a better way of building ductwork or running your company. So when you standardize the practice, you involve others in the problem solving progression. That's a really cool thing because when it's all on you, if launching the rockets was all on Elon Musk, he probably still wouldn't be off the ground, because he's not an engineer. I mean, he became an engineer after the fact, but he was not a rocket scientist. So he could not have gotten that rocket off the ground. And I think that's similar for us. You know, we run duct shops, we run these big companies, but we don't necessarily have all the knowledge. I don't know the last time Robin was on the coil line. It's probably been a minute, but we don't have all the knowledge of how to run everything perfectly. Our team does. And so when we involve others in that problem solving process, we get better results out of it. And then secondly, when you formalize the process, you normalize the process. I love this saying. So you formalize it and then you normalize it. If you provide your team with a recipe for success, success is normalized in your organization. So think about that. If you're leaving success up to chance because you don't have a good process, then you can't count on being successful all the time or even as often as you should be. So if you formalize this process and you create this recipe for success and you teach your people how to use it, which is the practical problem solving method, then that becomes the norm by which people operate, innovate, and solve problems. And what you'll find is your problems actually get solved and start going away. So the benefits of practical problem solving, like I said, it creates common understanding. It creates a faster response and it develops a sense of urgency, right? People want to move through the steps when you have the steps laid out and it's a clear path. It allows everyone to focus their time and energy on actually solving the problem, not debating and discussing things endlessly. So this is one of the issues too, when you're innovating and you get into these cycles of, well, we need to talk about it again. Well, we need to meet again on this. Well, I don't know. It's when you have a formula for problem solving, it actually allows you to expedite that process by saying, okay, we did this step, check. Let's do the next step, check. Let's do the next step, check. So it really helps you keep on track. It helps you take the time and proper steps to understand and solve problems and reduce the recurrence of problems. And then finally, it creates a ripple effect of creativity and waste reduction. So when you start innovating in one area, don't be surprised if you see other areas of your shop start to innovate as well. When you see a certain group or a certain individual start to apply some creative thinking to a problem that maybe you've been dealing with for a long time, don't be surprised if some of your other problems also start getting dealt with or thought about at least. So when you have this recipe, it inspires people to solve problems. So you guys ready for the recipe?
Yes.
All right, I'm going to teach you how to make the best sheet cake ever made here. So let's talk about the problem-solving progression. So to solve a problem, follow these steps. And if you see on the left-hand side, it shows you how it lines up with the PDCA cycle. That's probably the last time you'll hear me say PDCA, because I really don't like it. I don't like these super formulaic acronym things, because I think it gets away from the heart of the issue, which is problem solving in a way that allows you to be successful. So here's the first step. Identify the problem. Sounds simple, right? But not enough time is taken to actually identify what's causing the issue. So identify what the problem is, write it down, be crystal clear. If you're working in a group or with your team, be crystal clear. Everyone's on the same page. This is the problem, right? And then you move to the next step, which is you gather information and data. What do we know and what do we do now? So if you're thinking about making an improvement in your shop, it's like, okay, well, what do we know about this machine? What do we know about the flow of parts through the round department? What do we do now to build an elbow or to do a spiral head change? How have we done this in the past? And then you analyze the data. What are the root causes to our problem? What is causing this problem to occur? If maybe your problem is spiral head changes are taking way too long. Maybe they're taking 30 minutes in your shop. And so you want to get that number down significantly. So you say, okay, what do we know? So you've identified the problem. Spiral head changes take too long. You gather information. How long do they take? Let's measure it. Let's measure across 5 different operators. Let's measure on a Tuesday. Let's measure after your team loses the big game, right? Let's measure in some different data points here and get some information. Okay, it takes this. Now, what are the root causes to that time being so slow? Well, the operator has to walk across the shop to get the other head. Well, the guy has to walk around the spiral machine 16 times to get the job done. It's like, okay, these are issues that maybe we could tackle. And so you start brainstorming solutions. What could we do to be faster? What could we do differently to have a better process? And the best question right there on the end, what if, right? You always want to be in a what if mindset. And I think the problem is sometimes you run up against some resistance that says, oh, that's the way we've always done it, or that didn't work here, I tried it, or that'll never work. These are maybe some thoughts or even things that we say or others say that really stifle creativity. So I want you guys to be in that what if mindset instead. And then you pick a solution. So you've identified the problem, you've gathered data, you've analyzed it, you've brainstormed possible solutions, and now pick a solution. What's the best thing to do right now? What can we try right now? That's the planning stage. Now you go into the doing stage. So you plan your attack. How are we going to do it? Who's going to do it? When are they going to do it? Now you're getting really nitty gritty. You're basically just scheduling how you're going to do this thing. And then you test it out. You prototype that brainstorm solution of the best idea you have at the time. So you try it out. That's the do. And then you immediately go into analyzing results. So have we solved the problem? What did we learn? And I think if you go back to that SpaceX video, you see every time they test it out, the thing crashes. They test it out, the thing crashes. And every time they do that, they go back to the drawing board. They open up the blueprints. They see, what did we do wrong? They analyze thousands and thousands of data inputs that the rocket generated when it crashed. And we need to take the same approach. When something doesn't work, it's not well, I guess that didn't work. See you in 6 months when we remember that lean exists again, or whatever it may be, or I guess that didn't work, but we've got a 1 week lead time. So maybe we'll get to this when we can get that lead time back down. Whatever it may be, analyze your results and then use that to drive your next action. So analyze those results. Don't let it stop you. Analyze the results and then you go into act. And here's where you pick one of these things. So the first one, what should be the first one, is continue to improve. So regardless of whether it worked or not, we're going to continue to improve. So how can we improve on what we've done? So what we do in that do stage is never really a failure unless you let it be the last thing that you do. If you let it be the last thing you do, then you have failed. You can mark an F on that paper. But if you use that to generate new ideas and new ways to move forward, then you're continuing to improve. You're repeating that cycle. And so that's not a failure. That's an opportunity to do what you do better, to take that new information that you generated and make a better decision, make a better change, make a better improvement. And once you get it, once you get close to it, or you find a way that is actually better, you set that new standard. So say, going back to the head change thing, we found a way so the guy doesn't have to run around the machine 16 times, or we got the heads closer to the machine so he doesn't have to move as far and transport the thing. And we cut 5 minutes off our time. So we went from 30 minutes to 25 minutes. Fantastic, right? That is a huge win. So set the new standard. Here's our new process. Train your team, set that expectation, and away you go. And then finally, in the act is you want to share your genius. So you want to share that with everybody. And you also want to take the thinking that got you there, kind of like what Brady was talking about, and say, where else could we apply this thinking? Where else are we walking around the machine 16 times? Where else are we walking across the shop to grab a part that we need to do this 5 times a day? How can we get these things closer? And when you start thinking that way, you get this amazing ripple effect of innovation. So this is the problem-solving progression in a nutshell. This is the recipe for success. And this is a formula that you can use or you can give your team to solve problems, whether they're brand new or they're long-standing issues, or to innovate in any way you want. So what do you guys think about this problem-solving progression? Does this make sense to you?
It does. I mean, you find yourself as you go through that trying to think, okay, what should we approach? Which problem should we do, and who should I pull in to
Right.
come up with the information, the data, the analyzing, and
Yeah, thank you. Yeah, and I think when you look at a list like this too, and maybe you think back to times you tried to make an improvement or solve a problem before and it didn't work out, you can almost identify the area where it started to break down. Like, oh, I didn't get enough information before I started. I failed on the analyze the data one, or plan my attack. I didn't have the right guy do this, or I didn't give him enough time to really put together a good prototype. And as a result, we didn't really learn what we needed to learn, and we kind of wasted our time. So you can use this also to go back and previous failures and say, where did it break down and how can we patch it up to where it won't break down again? And I think that really speaks to, going back to this graphic, the process of innovation. So you plan what you're going to do to the best of your ability with the best knowledge you have. And now you have a fantastic formula that's going to help you get through this process faster and with more focus. And so you plan your attack, you attack, and then you check and see how it worked out. And then you use that information to go and plan again, right? Okay, now we have some new information. We know something different. Let's go make some adjustments and go act again. And then check it and act again. And this process can repeat multiple times, just like we saw with the rocket video. This went on and on and on over the course of 5-6 years until they nailed it. So it should not take that long to solve problems in a duct shop. I'm going to say most of our problems are not as complex as landing a rocket in the ocean from 100 miles up, but they certainly feel that hard sometimes, don't they? And some of these things that we've been fighting against for a long time, the whole goal of this methodology is to give you a tool that you can use to get out, to break the cycle and move forward and actually solve some of these long-standing problems and innovate in the ways in which you've wanted to innovate for a while. So that is, in a nutshell, the process of innovation. Brady or Dale, do you guys want to add anything to that?
I would just add that, no matter what the issue, the problem is, and frankly, you may not even be working on a specific problem. It's just back to, hey guys, we want to make this process less strenuous, less complicated for you. We want this process to be as straightforward, so it's as easy as possible for taking the complexity out and all of that stuff. And I think when team members actually get involved in that type of process where they're making their own work better, you're going to find a stronger buy-in, right? Because now they can see this process and they go, hey, if I can make this job a little bit easier, the long term is I'm going to be better for it. So no matter how complicated, no matter how big the problem or small the problem, this process of experimentation and trying and doing a ratchet type of effect of improvement is going to be the only model that's going to sustain growth in the shop and being able to increase their capacity and increase quality, safety, all of those things that are very important to us. This is the model that has proven over and over again.
Absolutely.
I'd like to add that when you're in the check phase, this is a group activity. Make sure that fingers aren't pointed, and if something doesn't work, that's like someone is singled out and blamed for the problem. You want to make sure that this is a group activity, and when you're doing your planning and you're doing it as a group, but also when you're doing your checking, you're doing it as a group, and it's not one person's idea that didn't work. It's a lesson we learned as a group and something we can use to push forward to the next act and plan phase of the process.
Absolutely.
That's a great point, Brady. Just as a note, whenever there was a failure with the rockets, Elon had some comment. When SN8 crashed, his response was, well, at least the crater was in the right spot, right? So he took that and said, we actually put the rocket where it was supposed to be. Now we just have to figure out how to keep it from blowing up, right?
Blowing up.
So yeah, so you just got to take what you learn and just keep moving forward. Yeah, that's a great point, Brady.
Excellent. Well, thank you, gentlemen. I want to leave you guys with one last thing. You should already have in your email inboxes your recipe for success. So we always want to give you a little something to keep this going and give you a little step up in solving your problems. And so we've provided for you a problem-solving worksheet. This is a really cool tool that you guys can use to start trying this model out, this PDCA model or the practical problem-solving progression. This is your recipe for success. So in your inboxes, you'll find a PDF of this, print it out, use it to solve problems, try it out, see how it feels and how it's different from maybe how you've innovated in the past or solved problems in the past. So this thing will take you through all 8 steps of the problem-solving progression. They're all broken out on the left-hand side with room to write your notes, write your key points on the right. They're color-coded to match the PDCA wheel, so you can see what part of that process you're in. And it's a tool that will serve to keep you focused. It acts as a historical log of what you actually tried, so that you don't have to go back and think and remember. I work with some organizations who use sheets like this, and they have file folders this thick from all the different things they've tried. And when they say, did we try this before? They open up the folder and they look at their sheet and they say, oh yeah, I forgot. We learned this and this and this, and it helps them make a change in the future. So it acts as a great change log for you, and it's already in your inbox. So I can't make it any easier than that. Go ahead, print this off, try it out, share it with people in your organization, and see if it's something that gets you excited. Because the bottom line, this is dipping the toe in what the Duct Manufacturing Alliance offers to duct shops. And we're really excited about tools like this and really using the right tool for the job. We're not going to give you 1,000,001 tools, but we are going to give you 10 tools and teach you how to use them extremely well. And so we're coming up to our hour here, guys, and it wouldn't be a DMA webinar without giving you a little DMA pitch. So you got to belt up and stick with me now. Robin's smiling because she's been through a number of these. So Robin,
I get to lean in. I get to lean in this, don't I? Just a little bit.
You know what? You can do the whole thing if you want, but
no. I would like to say this though, leading into this, it's something that just kind of a personal experience and thinking. This process I do know and lived it, and it absolutely is an amazing process. And I think the presentation has been phenomenal, guys. But the very beginning of this starts with identifying a problem. That's where it starts. And, I just had a vision, and this is interesting, a vision of me going to get my eyes checked out. And, before I can go in and get a new prescription or even think to, or get a new set of contacts, which I have in my eyes today, they make me go in. And when the doctor said to me, and they checked my eyes and all of a sudden showed me how bad my vision was, I was like, oh my goodness, I had no idea that my eyes were that bad. And then I now got to see that I had a problem. I didn't even understand the magnitude of the problem that I had. And identifying a problem, as I think I heard Jamie and Robin say, that people have been doing it that way. They don't even understand that they got a problem.
Yeah.
How are they going to identify a problem if they don't even understand that they have a problem? They've always done it this way and they're getting the job done. The beauty of the DMA is all of us that are involved in it get our eyes just open up like that optometrist visit that says, oh my goodness, I had no idea. And it excites them. And then implementing a process like that then becomes so good, because now that their horizons have been opened up, because as iron sharpens iron, all of these people are looking going, wow, there actually is a better way. And these people don't even know a better way, that they even have a problem, until they're actually exposed to different opportunities, and their horizons and their vision is opened up.
Great point. That's an
Good.
excellent point.
Absolutely. And I couldn't have said it better myself. So I'll wrap that up by saying what we've done with the DMA is we've paved the way for a lot of that. This is a system, lean and continuous improvement has been around for decades, but it hasn't been in the HVAC industry for very long. And if you know anything about lean and continuous improvement, you know that there's 1,000,001 different methodologies. There's 1,000 consultants in your area just ready and willing to take your money and try to teach you something. But it's not always relevant to our industry. And so what we offer is something that is incredibly relevant. We've taken the best business practices across different manufacturing industries and refined it down to what's super relevant and effective for duct manufacturers. This has all been tested in duct shops very successfully. We have a massive history of success with these principles, where we've taken from the entire cloud of lean and continuous improvement principles and really honed it down to the 5 or 6 things that make the biggest difference in a duct shop. And so keeping it simple, it's by duct builders, it's for duct builders, and it works in a duct shop. So as the reason why we do this is because a lot of duct manufacturers don't get the results they're looking for. And so in the Alliance, in the Duct Manufacturing Alliance, we offer continuous improvement training. We offer peer mastermind groups where you get to work with other companies who are going through the same process and solve problems together. And then we offer one-on-one coaching to help empower the owners, the managers, to engage the employees and improve their processes and reduce their costs. So in the system, it's a win-win for everybody. The customers get better products and shorter lead times. The owners and stakeholders get stronger bottom lines and profitability. The company has this incredible ability to grow in new ways, and the employees get to be a part of something amazing and have better opportunities and careers for themselves. So if you're interested in revolutionizing your duct manufacturing through continuous improvement, you definitely should be interested in the Duct Manufacturing Alliance. And we'd love to have conversations on how we can get this kind of training and so much more into your organizations, into the hearts and minds of your people, and get you connected with like-minded companies around the country and North America. So if that's of interest to you, we've got a few offerings coming up. First off, another webinar. We're doing one more this year. It's going to be in October. Date and topic to be determined. For those of you who have been in a few of these, we'd love to hear, like, what are you really excited about? What do you want to hear more about? So if you've got ideas, we want to hear that. But our next webinar will be in October. We will also be present at the AHR Expo in Las Vegas. This is going to be at the end of January, the 31st through February 2nd. We didn't get one last year due to COVID, sadly. So this will be a phenomenal opportunity to meet companies that are in the Alliance already, to meet us face to face, to see a great show, and just to rub shoulders together and sharpen each other up a bit. So those are our opportunities. And lastly, we would love to have a conversation with you about what the Duct Manufacturing Alliance is all about. We've got our resident experts here who are more than willing to have conversations with you. And we'd love to figure out how we can inject this into your culture and make your successful companies even more successful and long-term viable. So guys, thanks for coming to our webinar today. We appreciate you being here. Hopefully this has been of value to you, and hopefully you will be able to use that problem-solving progression recipe in your inbox to have greater success with your problem-solving and innovation moving forward. Are there any closing comments from Brady and Dale, and any final
Yeah, I would
questions
just,
from our
yeah, I
participants?
would just add, do not hesitate to call us if you want to dive more into that tool. Maybe you start looking at it and you've got some questions. Write or call. We're here to help you understand and execute on that tool as best as possible.
All right.
Good job.
Okay. Thank you, everybody, for being here. Have a wonderful rest of your Thursday and a great weekend. Keep your chins up and keep going and growing and improving and solving your problems. We will see you all soon. Thanks for being here, guys.
Thank you.
Thanks.
Thank you.